dispersion, or what is the dispersion is. Dispersion. So let's understand the dispersion. So how we can define the dispersion? Dispersion is any heterogeneous system which composed from the two component, or according to our PowerPoint presentation, dispersion is the heterogeneous dispersed system in which one substance is divided into its minute particle and other is divided throughout the second substance. Usually the second substance is solvent में जो सेकंड हमारा सब्सटेंस होता है वो सॉल्वेंट स्टेट में प्रेजेंट रहता है. So let's understand the meaning of dispersion by taking an example of solution. As we know, the solution is composed from two components, solute and solvent. So if you consider solution as a dispersion, then we got that solution in solution solute is present at a dispersed phase and solvent is present at a dispersion medium. So we conclude that solvent or the dispersion medium is always present in abundant form or the large extent as compared to the dispersed phase or the dispersion phase. So we define dispersion as dispersion. It is a heterogeneous system in which the dispersed phase is distributed in the dispersion medium. So dispersion में dispersed phase distribute होती है किसमें? Dispersion medium में. So here we complete the definition. Here we complete the definition of dispersion. Let's see some example of dispersion. So as we know, the dispersion is composed from two different phases, that is the dispersion phase and dispersion medium. Dispersion phase contains the solid particles or somewhere solute in case of solution, while the dispersion medium is usually solvent or liquid in state. So our first example is foam. So foam is a common type of dispersion in which the consists of two phases. One is present as a dispersed phase and other is as a dispersion medium. So in case of foam, the gas is present as a dispersed phase while the liquid is present as a dispersion medium, because as we know, the in foam liquid is present as a abundant concentration or at a large extent. After that, second one example is solid foam. Solid foam is consist from the two phases or two component, that is solid and gas. It is the combination of three substances, solid, liquid and gases. So in case of solid foam, if you consider the solid foam as a dispersion, we got dispersed phase is consist of gas or composed from the gas and dispersion medium is from the liquid. So now third one is liquid aerosol. As we know, the liquid aerosol or aerosol is the medicinal formulation which works on the pressure phenomena or the gas pressure phenomena. So in a liquid aerosol, the dispersed phase is gas and dispersion medium is liquid because it present in a abundant concentration. The fourth one is suspension. Suspension is a medicinal formulation in which these solid particles are suspended in liquids. So as we know, the solid particles are suspended in liquid. So here the liquid is present at a large extent. So if we consider suspension as a dispersion, we got solid are present in dispersed phase or dispersed phase particle and liquid is present in the form of dispersed medium or the dispersion medium. So as we say in emulsion, there is a presence of continuous phase is there. So likewise in dispersion also continuous phase is present, which is at a large extent. We call that as a dispersion medium. So let's move towards the types of dispersion. We classify dispersion on the basis of dispersed phase particle size. So there are three types of dispersion. First one is the molecular dispersion, second one is colloidal dispersion, and third one is coarse dispersion. So let's begin with the molecular dispersion. Molecular dispersion, it is such type of dispersion system in which the dispersed phase particle has size less than the 0.01 micrometer. Molecular dispersion has dispersed phase particle of size less than 0.01 micrometer. Example of molecular dispersion is NaCl in water. As you know, if we dissolve the NaCl in water, the homogeneous solution is formed because molecular dispersion has molecular level or the size of particle is very less. So there is no any difference in between the disperse phase and dispersion medium is seen clearly. Second one is the colloidal dispersion. Colloidal dispersion, it is such type of dispersion system in which the particle size or dispersed phase particle size ranges from 0.5 micrometer to 1 micrometer. And example is acacia in water. Colloidal system or colloidal particle has size much greater than the molecular dispersion. So we can say or we can see the dispersed phase particle by means of electron microscope. Third one types of dispersion is quartz dispersion. It is a dispersion in which the particle size or dispersed phase particle size is greater than 10 micrometer up to the 1000 micrometer. Example is emulsion and suspension. This type of dispersion we observe through the eyes. We observe through the naked eyes, and here no requirement of any microscopic device is required. For example, in suspension, as you know, in suspension the solid particles are dispersed in the liquid. So in suspension we easily observe the solid particles are suspended in liquid. So let's deal with our core topic, that is the colloidal dispersion. We can define colloidal dispersion on the basis of two criteria. How the dispersed phase particle are distributed in the dispersion medium, and the second one criteria is particle size of dispersion phase. So firstly, let's deal with the definition of colloidal dispersion on the basis of how the dispersed phase particles are distributed in the dispersion medium. So we can define dispersion as dispersion. Colloidal dispersion is such type of dispersion system in which the dispersed phase particles are uniformly distributed throughout the dispersion medium. So in case of colloidal dispersion, the dispersed phase particles are uniformly distributed. Uniformly means throughoutly. Let's consider this is a type of dispersion medium in which the dispersed phase particles are uniformly distributed, means distribute throughoutly. Here the all dispersion medium part taken by the dispersed phase particles. Dispersed phase, and this all is the dispersion medium. Second criteria of defining colloidal dispersion is the size of dispersed phase particle. So on the basis of the size of dispersed phase particle, we define the colloidal dispersion as follows. Colloidal dispersion, it is a such type of dispersion system in which the dispersed phase particle has the size ranges from 0.5 micrometer to 1 micrometer. So let's or understand the colloidal dispersion by taking an example. For example, dust. In dust, as we know, the dust particles are uniformly distributed in the air. So dust is a type of colloidal dispersion. So let's see the some application of colloidal dispersion. So our first application is in therapy. As we know, the silver has germicidal properties. So in many therapies, silver is used as a germicidal. Dispersion of silver. While the other example is dispersion of copper is used in chronic disease like anti-cancer. Third one is the dispersion of mercury. Mercury is used against the most common sexually transmitted disease, that is the syphilis. So dispersion of mercury is used as a anticephalus. Second one is the absorption. As we know, the absorption is needed to show the therapeutic or desired action of that formulation. So colloidal dispersion has greater absorption rate than the coarse dispersion. As we know, the colloidal dispersion particle has the less size than the coarse dispersion. Third one is the solubility. Surface active agent influence or enhance the solubility by decreasing the surface tension. As the surface tension decreases, the solubility is increases. Fourth one is the drug storage. As we know, the 90% of metabolism of any drugs it takes place in liver. So in novel drug delivery system, the liposome is used to target the drug towards the liver. For example, iron resting injection or iron sorbitol injection. So our next topic is property of colloidal dispersion. There are five main properties of colloidal dispersion is given by various scientists. So our first scientist or the property is given by great scientist Tyndall in the year of 1869. The property is known as Tyndall effect. The property is known as Tyndall effect. According to Tyndall, when we pass beam of light through the colloidal solution, the path of light is get illuminated by the scattering of light. Scattering of light is happens or occur due to the presence of dispersed phase particles in the colloidal solution. On the basis of this, he proposed a relationship which given below. Intensity of scattered light is directly proportional to the refractive index or the difference in refractive indices of dispersed phase and dispersion medium. So, what proposed by the Tyndall? Tyndall says that the intensity of scattered light is directly proportional or equal to the difference of refractive indices of dispersed phase and dispersion medium. By means of follow image, we can understand the Tyndall effect. As you know, the beam of light transfer the light beam throughout the colloidal solution, and scattering or the path of light is illuminate due to the presence of colloidal particle, and scattering of light due to the presence of colloidal particle.